Okay. So the first problem I'm going to do is the divisor game. And these are the directions that are on the site. So basically, we're going n number of times um, based on the parameters that are given to us. And the way that LeetCode works is you'll be given multiple up to 70 different test cases.
Everybody. Today we've got a couple of guests from Valero. They'll be talking about what it is they do as software engineers in a enterprise setting. But before we get to that, we do have a couple of.
Didn't know that was going to pop up.
I was confused.
UTSA.
Oh.
Their ACM on their YouTube channel. I was looking at some stuff earlier, and I forgot they were doing a live event tonight. So there'll be like up to 70, even sometimes more test cases. So you'll get essentially 70 different ends that will pass through the one method you're expected to build. So in the first example, I got cut off. I'm gonna fix that up. It should be true, not just true. So in the first example, there is two that comes through as n. So n equals 2, and the result is true. So what's going on is Alice and Bob are playing a game. Alice always goes first. And depending on the number of turns, okay, the person who can no longer do another turn is the loser. So in this case, if there's 2 turns, it's true because she's going to win because there's no other turns that she needs to make, so she doesn't have to make a move. Or I'm sorry, yeah, for 2. And then 3, when 3 comes in the second example, she chooses one, Bob chooses one, and then Alice, because she's already chosen, she can't choose again, so she's going to be false. So when it's anywhere up to 1,000, n could be anywhere up to 1,000, and it's so as long as Bob can make another move. So for example, if input was 4, then it would be true because Alice can choose 2 and Bob can choose 2, but they can't be uneven. So either Alice wins or Bob wins, and true is when Alice wins and false is when Bob wins. So we're basically just trying to pull out when it's odd, but it's not quite that easy because there's times where it's going to be a little bit different than just the n to 2 module. It's actually n to the x module. So we don't really know what x is, so we have to figure out kind of in the program what x is going to be. So that's kind of the challenge of, if it was just 2 all the time, it'd be pretty straightforward. But because we have an unknown variable, this is where it becomes one of what they term the dynamic programming problems. And that's when we start getting into the crazy big O's in like either O2, O3, or n to the 2, n to the n squared or n cubed, I should say. And then also a polynomial where it could be 2 to the n. And unfortunately, there's not a whole lot of ways to get around that with some of the problems. So what we want to do in kind of the technique that we would like to get you to think about is, and this is the umpire technique. You were here the last one, right? Did we talk about did we talk about umpire at that point?
Yes, I wrote it down. Yeah.
Okay, so to understand the match and the plan. So we're going to just do that in the HackMD file here. So if you click on that link, it'll take you to this page, and I'm going to do it as split so we can see the code and the screen at the same time. So understanding, this is where it's going to get a little tricky for us, because we need to figure out really what that N means, if you will, because we know that, so what's going to happen when, N in this case is equal to 4. So 4 is our input. We should expect it to be true, but we have, the turns are, if they play optimally, Alice should win the game then. She should. Because at that point, Bob will not be able to make a move. So we should return true in that case. It should be. And then, for example, N to 5 would be false, because Bob makes the last moves and then Alice can't move. And then, like, conversely, if we were given an N at 0, then that would be false as well. I mean, it should be on the odds, but it has the potential to not be that way. If that makes sense. And we shouldn't have any negative numbers.
Yep.
All right. So matching up, you haven't seen a problem like this before, and I'm not really sure that I can match it to any problems that I've seen before either. I just know that it's going to be dynamic programming problem, and that's about it. And most of those, so when you're doing the dynamic programming, you're typically going to be, I'm trying to do this. How do I do bullets? Bullet, I think is a bullet. Saving information in another array. You could also be doing max, min, depending on the circumstance, to determine best outcomes. And what else will you typically do? Because it's almost as if, and I don't know if this problem necessarily equates to the same way, but on the next problem, on the house robber, which is also dynamic, and when you get into algorithms and you do the backpack problem and the pipe cutting problem, rod cutting problem and stuff, which are dynamic dynamic programming problems as well. You can put the information into into a matrix, into a 2D array, and actually see how everything should change. But in this one, I don't know if we could do that correctly. But we can do. We'll definitely do it on the next one. So I'll do. So in terms of this one, when we start thinking about how we're going to go about it, it's going to be. Oops. Oh, there's Harry. Hey, Harry.
Hey, so I'm late.
Oh, that's all right. I'm sorry I didn't post the link onto JagSync like I was supposed to. That's my fault.
No, you're good. Can I get a synopsis? I mean, you said hacking, but what exactly are you doing?
All right. So we're trying to solve this problem here. Or are you talking about the hackathon or?
Actually, a little bit of it all, yeah. And I'm trying
Okay.
to understand what you're trying to do with the problem. Like, what problem are you trying to solve?
All right, so we're trying to solve this problem here, the divisor game. You can see it up here on your screen, I hope.
Yeah, I see it.
Okay, so this is all the information we're given from, and this is off of LeetCode.com. So we're given an input on our first test case of 2, and on the second test case of 3, and we're expecting to return true on the first test case because Alice chooses one time, and then Bob doesn't have another move. So that X at this case will be 1.
It's only true because she gets a choice and he doesn't.
Correct.
When
And
they both do the choice, it's false.
right. Alice doesn't get another move, so within 3. So it's trying to figure out is, so when we get to 2, we obviously have, if there's 1 left, then Bob doesn't get to move. And this conversely here. So really our X, when we talk about the when N comes in as 2, our X really is 1. So we only have that 1 move.
Yeah.
It goes the same way with 3. And we're trying to figure out if it changes dramatically when we get higher numbers, or is it going to be that consistent 1 all the way
Kind of
through?
like an odd or even thing.
Yeah. So I should have given that. So the other thing is, so that we have to think about too, is N when it comes in is an integer, and then we're outputting a Boolean. So we have to somehow kind of work that magic in our loops or in our if statement somewhere where that, depending on where we're at, we can then cross over to Boolean. And I think in this case, because we have the different moves, that it may be best, because I was talking about, I don't know if you got here or not, some of the ways that we kind of solve the problems I kind of listed off under the match thing.
Yeah.
And let me put this in the chat for you too, so you can get on the page. So one of the ways that we try to solve the dynamic programming problems is to save the information in an array so that we can kind of then go back into that array and pull out the answer as we cumulatively collect it throughout the program. Because it's not, when it comes to the dynamic programming, it's not as straightforward as just putting in a a for loop, and in this case, taking, subtracting 1 from N, and then doing a module of 2 to figure out if it's 0 or 1, and then just placing the true or false, depending on whether it's 0 or 1. It's a little bit more tricky than that because of the turns of the, and it comes here that N minus X because we're not sure, we don't know what X is always going to be.
So even in, as it says that, the value, it's just some value. It
Right.
never defines if you start at 1 or maybe not even at 1, even though it says input 2. So
Right. Because we only get, when input's 2, we only get one move. Why do we only get one move if there's supposedly n is 2? So that's why we have that n minus x. So in the case of 2, it's 1, same with 3. But as we grow higher in number, how does that change? We're anticipating it to change, but we don't know how it's going to change.
Well, here's a point, and I'm probably just thinking.
That's all right. That's why we're here.
So if the input that's put in is 2, and only one person, it just happened to be Alice, she went first. It's going to be the value minus the choices, minus 1 from the choices. So it's always going to be 1 less. Because now you have a 3, and now they both get a choice apiece because she gets another turn.
Right.
And then he gets a turn. So it's always going to be the choice. It's going to be the input, is going to be -1, and then there's your choice. Because from what information I'm seeing, since it's a 2 minus 1, okay, now we'll just let one person get a choice. Oh, Alice is first, so she gets it. That makes sense, or am I kind of?
It does make sense, but I don't know if that is always going to hold true.
Yeah, because you only have 2 examples.
Right.
And
so when our input gets up to, like, say 101, am I still going to expect that X is still only 1? Or will it be moving based on, some relative thing that we aren't seeing right now?
Well, even you say that in your notes here, it's 1 less than or equal to the value of n, then less than or equal to, say, up to 1,000.
Right. But also X is greater than 0, but less than n.
Yeah.
And then that n modulo X equals 0. So
the remainder of it, yeah.
Yeah. So,
and see, that still comes back to whether it be, if it's say if 2 as in the number of values divide evenly, then.
So in this case of 3, X was 3?
Will be a remainder.
Yeah, or 1.
Well, it's the remainder. No, because I see a little pattern. 2, and then one person gets a choice. Okay, well, that's 1 less than what was put in. And then 3 comes around and, well, that's okay, they both get a choice. Well, that's still 1 less, because you could if it was really going to be simple, and of course the choosing any X is nice. I like that. But the pattern that I see, at leads in the 2 examples, leads me to that.
Right. And we think that at least when we go up to 4 or 5, we should hold that same pattern to be true.
Yeah, because then there's, from 4, that it'll be one person will get 2 choices, because if it's holding to the that sequence, and then 5, they both will get 2 choices, and you keep going. Now 0 is going to be kind of weird.
But when we get to 4, what if our X is 2?
Good point.
It has to that divide by n and have 0 remainder. So it may be 2 at this point.
Yeah.
And in that case, then it'll be true, right? So, but
yes,
5.
That's true. Then it's still going to be that remainder of 1.
But yes, but so let's say what can I divide 5 by to get a 0? And really, it's either 5 or 1.
Yeah. Yeah.
So if it's 1, then Alice gets to choose. So that 5 should really probably be true.
Also, if a player cannot make a move, they lose the game.
Right.
Wow.
So 5
So
might
it
be true.
won't be 0.
Yeah. So I think 5 may be true because 5 can
Yeah.
only, you can only divide it by 1 or by 5. So Alice would go 1 time, and then Bob wouldn't have a move. Or
So,
they would go Alice, Bob, Alice, Bob, Alice.
so
Bob
here's a
wouldn't have
funny
a move.
thing that, as I'm reading further, it says return true if and only if Alice wins
Right. Right. Yeah.
the game, assuming both players play. So, that's a good one. I like that. I like this little puzzle.
All right. So when we start thinking about our pseudocode or our comments,
Yeah.
I think, and this is based off the first dynamic
Yeah.
saving information on the array, is probably creating a Boolean array to start this off. Oop. I'll put that there so that when we go to paste it, everything works out. And then we will probably, so n start at 0. So yeah, because the first one would probably be, because it would start at 0, so we'd probably go n plus 1
Yeah.
for 1.
So the length would have to be, if the notes are right, the value up to 11. I'm sorry, 1,000.
Yes. So if n's 1,000, if we give it a length of n, it'll be 999.
Yes.
So we have to give that extra 1. So then I would think we probably have to iterate the turns. So I would say, so again, we'd start, I think it's sort of 1 because we're not starting at 0.
Yeah, correct.
So from 1 to n. And then in there, so in here, if we go and do anything, so we go 1, so go through the first one. We don't want to turn everyone true because not everyone's going to be true. Some have to be true and some have to be false. But we don't know which quote unquote turns those are going to be.
Correct.
Because if like I said, if n is 5, we might only get 1 turn, or we might get 5 turns. And so you might end up with true, or you end up with a bunch of falses. And then you end up with a bunch of trues.
Is the input each chance that they're playing the game, or is it a series as they play the game? Like, okay,
So each input is a game.
Okay, that's what I wanted to hear. Okay.
Yeah. And it could be, and like I was telling Emily before, the test cases are there's somewhere close to between 60 and 80 test cases. So there'll be 60 or 70 different games that'll be played within LeetCode to test to see if your algorithm is correct against those test cases.
Any x with 0.
So it might be correct against, say, 10 cases, but it fails against, 50. So then you still have to go back and modify and figure out why it's only doing 10 and not 60.
0. So if x is the iteration of a game,
And I think if, yeah, and I think you said it right there. I think if we do another loop, we do a nested loop and iterate through X.
Because the n is going to be what they're inputting, what the person's inputting in, whether it be Alice or Bob.
Right.
But he goes first. Yeah, because it'll be x, say, is 1. And then the value, and we'll pick 2 because it says it as an example. And then that mod remainder.
Yeah. And I think in this case, we'll probably only go up through I, right? Because it's the inner. So every time we go I, yeah.
Because if the n is what they're being put in, and then you're looking at the next iteration of the game.
Right.
2, and then enter a 3.
Yeah, like you said, we'll do if.
And then the mod of that would be a 1. But they each get a turn. I wonder if the turns themselves, as you're choosing the game 1, game 2, not just, of course, the input in.
Is it 1 or I think it's going to be 0 at this point?
But if the input is, say, and this is, I'm only going with I mean, it could change if the input's greater than 2 for the first iteration of the game. That's what I'm looking at. Because if it's 1 and a 3.
Yeah, I'm just going with this here.
Yeah, I'm trying to read it too and piece it in my head, like normal little problem solving. And the real funny thing is, I got coworkers that do kind of the same thing and make up their own little problems. I'm like, oh man, I got real world problems, like projects. But it does help though, because then you think outside the box a little bit.
Yeah. I think if we do. So when we make the Boolean, it's everything's going to be false in there. So if we just mark it the one that we need to be true by breaking it out. So if Boolean to be X, I don't know which other one.
And see, the thing that, as you're putting that in, the thing that, because you're looking at the Boolean value as defined, and it just happened to be either even or odd. I don't know if that's 100%, but it's leaning that way.
Yeah.
Even
I think we'll stick with even first and see what it tells us.
Then it's going to be the other. Yeah. And that's, you're still looking at the,
this is true.
That's what I'm thinking about now, the mod.
And if it gets true here, I think that's it, right?
Yeah. Yeah.
So we can break and be done with it. And then there should be
return Boolean, correct?
Boolean at, well, it's
I.
Well, I think it would be n at that point.
Oh, n.
Yeah, I think these are the same. I think n and I are going to end up being the same.
Mm-hmm.
Yeah, because I will go up to, and I should anyways. So when it's on there, when it's going through the inner loop, it'll find the last one, but it'll be I, which will be N at that point. Because we're starting at 1. Since we're starting at 1, that'll be, yeah, because this should be to N, so it'll equal N. So we can either do either I or N. I don't think it'll matter. But since we'll probably just do I inside the loop, inside the for loop, we'll have to use N. But it's the same index. I'm guessing. I did not set these up. I should have set these up. Link for you guys. So this is going to be. To be static because we're in the main text. And here I'll be advisor. It takes an int. Oh man. Back here, copy this out. So this should be all we need to do to run right through this pretty easily once. So the key point of the umpire method, which we are attempting to do, Harry, which is the understand, the match, the plan, and now we're in the I stage, which is implement. So we're looking to put a lot of our time and effort into the understanding, planning, and matching stage, and then doing a minimal amount of time in our implementing stage, because at this point we should, with our pseudocode or the comments we used, either one, we should easily be able to write the code out at this point. So it should take us 5 or 6 minutes to get it all done, unless it gets too intense, which can happen on some problems. And this is kind of, this will help you not only in class, but it's really meant to help you in interviews. Everyone loves the technical interviews. So let's start with a Boolean. And let's just call this as turns or turn. Turns. That'll be new Boolean. We said that's going to go n plus 1 in length. So there's our first line. Everything looks good there. They're not yelling at us. And we'll iterate. So for this, the for loop is going to work best. We could do it in a while loop, but it's going to get a little crazy to do it that way. It's, we don't want to change n, so we'll use I as a replacement. And we'll start at 1. And then we're going to go I less than and equals to n. And then we'll increment I to get out. And we're going to do an inner loop. So, I would typically use J here, but I'm going to go with X because it hasn't been used yet. It will at least stick with us on the pattern so we can remember where we're at. All right, so X will go up to I. And we will increment, oh, and we will increment X. And then I think if we do I modulo X equals 0, two lines here, so I'm in brackets. So I'm up with, in this case, it'll be terms I, which is our n really. It's true. And we'll then break out of our loop because that'll be our answer. And we will, oops, return terms at n, which is what our I should be at this point. So if we int n equals, let's start with our 2. 9, 3, n. Let's see what happens. So true. That was correct, right? True was for 2. Yeah, that was correct for 2. So we change it to 3. Expect false. Oh, we're expecting false. We got true. So the only way that would have happened is if this if statement turned. So we need something else in here.
You have I in there. Are you moving the value of n to I? Because you're actually
It's basically yes, because it happens right here.
Okay.
That's all.
Less than or equal to n. Yeah, and that's what that said to do. So it's not
It'll be up to n.
not too crazy.
So at some point here,
Unless you have to make I. No, it can't be 0. It has to be a 1.
Yeah.
No, you have to start at 1. No, that's not going to work.
So we just need, I think we just need another parameter here. So if it equals 0 and something. Oh, well, there we go. We don't want it to be changed if it's not I, right?
Correct.
So if it's I at this point and we subtract x, because it should be, can we get up there, right? Is that correct? Is it subtracting x? So if I is 1, for example, and x is 1, that becomes 0, so that would be true. If x is 2, and 1 is 1, and I guess that would, oh. So this is good, but if it's not this, we don't want it. So when it's not x minus 1 or I minus x, then we're going to move on. Because it's going to be false if it's not this. So we can't change it to true. Because every time it's I minus x, it's true. And I think it's here in the, yeah, I minus x. So if it's not I minus x, then it has to be false. So we won't change it if it's not.
I can't argue that.
So I'm wondering what 5 comes out to.
Should be the same.
Oh, it is
Yeah.
false.
Yeah, because that's even and odd. If you make it like, yeah, something like that, that should return still. Yeah. Now you put something like 18 or 20 or something like that, it should come back true. There you go. That should
Well,
still
I think I
be
go over 1,000, right?
correct. Well, I didn't see you put that value in there, but
No, I was going to. It's gonna get crazy.
if you make it, yeah, something like that, because it's still, yeah, odd or even.
It's odd or even. We should have been easily able to do just the module.
Well, I also think what they put as conditions, that's what throws you off.
Yeah, maybe. All right. So I'll put this one in. So this is the actual LeetCode page problem. So that's how I saw this the other day.
Now, you trying to get the same output they got, or is true and false enough?
Yeah, true or false. Yeah, that's all. It's the output's true or false.
Yeah.
So I could just run it against the first test case, then it'll come up as true. And then when I submit, I haven't changed it. So I'm not fast on this one. It's kind of slow. There are other ways to do it. I went with the dual loop on this one, which I think is bottom-up approach for the dynamic programming.
Interesting.
So that's our first one. You guys have the repellates. You have the code there if you want to join up with LeetCode and get that stuff going. Up to you. So I'm going to close this page down, and then we have our second problem, which is the house robber. So the house robber, he wants to rob your house. All right, and this basically goes kind of the same way on the odd or even type thing. He can't do two houses in a row. All right. So because he can't do two houses in a row, he can't, for example, in the second example, hit just houses 7 and 9 and make the most money at 16. He has to go to either 2, 9, and 1 or 7 and 3. He has to always skip a house, otherwise the alarms will get tripped. He can come back the next night and do it, but not in this program. So you can kind of finagle it around, but the most money that the guy's likely to get is just to do a collection of all the odds and a collection of all the evens. So the question is collecting that information and then also figuring out which of the two totals is going to be our winner.
So that last part again, going to be our what?
Which of the even or odd is going to be our winner? Who's going to be the highest amount that we robbed, the max value? So like in the first case, it's simply the odd ones, 1 and 3. And in the second case, it's, well, I guess it's odd again. But if you put a, like a, put a 1, and let's just say we put a 3 here, then the even wins. Because we'd have 7, 3, and 3, which would be 13, twice the 2, the 9, 11, and then 12. So how do we, I think it's easy probably to fill up or, determine the sums of each of these, but then we need to compare the two. And how do we effectively compare them?
Good one.
So this is for dynamic programming problems. This is this. I gotta spell that right. Well, let me give you guys this one too. So I think this one is kind of straightforward. I don't think it's too complicated. We'll just, like mentioned on the last one, we typically either use like arrays, or in this case, we'll end up using the math min or max type concept. So whichever is the maximum number, we'll store that, and we'll hold that and compare that against the ensuing. We'll compare the two, the odd total and the even total. And it shouldn't. It's not going to get too out of control. I think we can iterate in one loop and use a couple if an if statement to do to get the evens or the odds, sum them all up, and then compare the two numbers. Anyone see anything different on that?
No, no, I don't.
Yeah, I think it's that simple. I don't think it's too crazy. So we are, because all we're doing is we're taking in an array of numbers, of integers, I should say, because it's nums. I got confused. And then we're outputting another integer, just a single integer, so we don't have to get crazy, and we can just count it up or add them all together, sum them up with the combination operator of plus and equals. And then just do our comparisons between the two values, whichever one's higher at the time, to give us the final answer. So I think on this particular one, because it's an array and not just an n, probably do like a base case, even though this isn't recursion, but if return 0 if array is empty. That way we just don't have to worry about going through the entire process if there's nothing actually in the array. Which, the way the LeetCode goes, will inevitably give you an empty array. So I'd say we need odd and even variables. Since we're tracking every other house, and we'll iterate from 0 to length of nums. So we'll go through the entire array, and then we could do either way here. We'll just start with the easy one out of it. And we take the if I is 2 and 2 even, else add to odd. Return biggest number of even, even or
Hey, Leo, I'm going to drop off, okay?
okay, no problem.
All right, man. Thanks.
So the one thing that we're going to have to do here is we could test this at the end and just return the max at the return, but we may want to also compare in the if statements. I think that should do it. I don't think it's going to be too crazy here. We'll just take that and come over. Put this in. Share this out to you. We just need a public static again. And we're returning an int. Let's call it Rob. And we're taking in the int nums. I don't know why I keep doing that. And it's an array. So the base case we'll do is be something like this. Nums dot length is 0, and we're going to return 0 because there's no value. And so if we get that empty array, we don't have to worry about trying to go through crap. And when we start trying to divide 0, and it doesn't work. So we need a couple variables. So int or odd, or even the first one in the alphabet. Initialize it. Int odd. 0. Major. We'll do our for loop. So what we can do is this ternary here? We're going to try our the ternary. Where is it? Let's see the operators. It's something they don't really tell us in school. Let's see if I have an example of this one. So in any case, we'll try it with the. So there's the ternary, the unary, and the I think it's the binary operators, and the ternary is the question mark and the semicolon. And in this case, we're going to use the semicolon, and we're going to do a for loop a little bit different here. And we're just going to call it num. So int nums will be our this is essentially going to be our nums index I. And then we're going to use the semicolon and then go through nums. So it's a little shorthand for doing a for loop. I think she might have had us do this in Android once, but I don't remember. I'm pretty sure we did it a couple times this summer though in the web. You were in web, right?
Yes.
Yeah. So and we did it in JavaScript, but it's just, we can do the same thing in Java. All right. So we'll do if. So in this case, num is 2 equals 0. Then what we're going to do, I think we're going to probably have to compare. So we have to first, so even plus equals to, that should just be num. Because what we're doing there is just adding the num's I. Oops, what happened to me? The num's I, which is num in this case. And then we're going to compare. So, right, we're going to compare and we're going to hold it as even. So we'll compare, and if even is greater than odd, right? And now we're going to definitely do the ternary. We're going to do, so this will be basically a shorthand for if. So our condition being is even is greater than odd. If that's the case, then we're going to say that even is going to equal to even. And if it's not the case, we're going to say that odd is equal to even. And I think we might have done this a time or two, but I don't remember if we did or not.
I don't remember either. Yeah. Not like that, at least.
Yeah. But so this is basically, this is your condition part of an if statement. And then this is your if code, and this is your else code. So basically, this is going to be, in this case, our math max. If even's greater, then we're going to return even. But what this will do too is doing it in an if statement instead of a using the math class and then the max method. It'll save us on processing time. Not a whole lot, but we'll save a millisecond or two. But when it gets too big, then it can certainly be a help. So do else, and we're going to do the same thing down here. So I'm just going to copy and cheat a little bit. Except we're going to change odd. But we're going to change, we're going to leave the same, because that's going to be our, we're going to keep this as our same parameters. We could flip it around, but we don't have to, because it's still going to give us the same, you know, if odd's greater, it's still going to be odd.
Yeah.
So it's just as easy to copy and paste. Right. Then we'll return the greatest. So we can actually just use that same one again. Just in case. Oops. I do not need the equal sign. So again, we're going to return whatever the two greatest ones are. So if somehow when we went through the if else's, it didn't do it right, then we have that other maths, if you will, in shorthand and in less space. So we need the numbers over there. Right? Oh. And we're going to go to next line. And we're going to go to Rob. And the numbers there. And right now, for example, we're empty. So when we run it, we should get 0. We shouldn't get an error. So what was our first test case? Let's take the second test case. Oh, come on. Zoom gets in my way and I can't get to it. Put that in there and we'll run and we should get 12. We got 20. Uh-oh. What did we do wrong? I wonder if, oh, you know why? Because I look, because this is modulating wrong. I don't think we can do the shorthand loop here. Because that's not really I, that's the value of nums at I. So we're gonna get a wrong answer every time. It's worth a try. So nums length equals I plus. So now we have to change this to I. We have to change this to nums at I. Now I have to change this to, I think that's how we have to change. It'll tell us one way or the other. Yeah, all right, so now we get 12. So let's just make sure we'll test this other one that we have. Oops, I need to. Enter does not make it run. So we have 4, and I think that was the answer over there, right? Yes, 4,
Yep.
okay. So we have this. I'm just gonna go back. I'm gonna grab that last one again. I'm gonna do the other test case that I added the 3 to it. So 3. And so here we should get 13. Is it running? Did I break it? Okay. I don't know what's going on. All right. So is that 14? 6. Uh-oh. And then should be 13. What happened? So why did we get 14 and not 13? Because 3 plus 3 plus 7 equals 13. The other way is 12. Right. I don't know what it is up here. Let's fix it. We'll walk ourselves through this thing while there is, so everything should be good. We got too complex, we can't do stuff like stacks or queues or lists. Doesn't like it. Right. So, right. So even is 2. Odd is 7. I is 2. Everything is good. Even is now 11 is correct. Odd is going to go up to 8, hopefully. Whoa. Oh, 10. This is 3, sorry. Oh, okay. Because it did that. So that's not what we want. So if we do I don't need these here. No. Comment those two lines out and see what happens. Yeah. All right, so evens 2, 7, 11, 10, 12, 13. No, we're returning 13. Okay. Guess we don't need those. Mess us up. Oh, okay. Do you need those? Because we don't always have to be just odd or even. That's why. It's the greatest, not just the. Because we were counting it wrong a little bit here. So let's go back to what we got here. This is odd. So what happens is 10, 14. So how do we get the? We get 2, 9. Oops. Some executions. I love this thing. This is well, this isn't Dr. Yang's, but Dr. Yang has a project like this. She's trying to build one of these out. Oh, yes. Yes, yes, yes. So that's exact. Well, it should be 14 because 3. They got the two houses together. That's the problem. Let's see. Oh, no, they skipped 1. That's what it is. Okay. So in this case, they took the 2 and the 9, which was 11, right? And then we skipped 3 and 1. And then added the 3 to 11 to get 14. And that's why it's dynamic programming. Let's get it all solved, and then you're not quite there. Okay. So I'll just check this in. So when we do it, we actually are pretty fast because we didn't use the math mix. All right, see, I plugged it in as without those to see if it worked, and it didn't work. Because it came out with the wrong answer. It was 2112. Because if we just went odd or even here, we would get either 3 or 3. But we could do the first and the last without getting the houses next to each other and come up with a 4. So that's our max value. So that's what occurred there. Oops, I stopped sharing. Hit the wrong button. I'm going to put this in the wrong button. So it's actually called Python Tutor, the visualizer that I have, but you just click on the Java option on the front page.
Oh, okay.
I can get back there, but apparently I can't. It takes you to another subsite. And there's a couple out there. You can just Google Java Visualizer, and it helps you out. It's kind of like when in like programming 3, she'd show you the visualizers for the sorting online.
Oh, yeah.
Yeah, this kind of works the same way, but it actually goes through your entire code, just as long as your code isn't too crazy on the libraries and stuff. It doesn't like if you have to do like util and stuff, which means a lot of the stuff is kind of off. All right, so that's house robber. So our last one, I don't know how much we'll get to. Let me see. So we're the dominoes. So this is not a dynamic programming. This is just an arrays.
You're not screen sharing.
Oh, sorry.
You're good.
Oh man, I feel like Dr. Yang. Good thing it's only the 2 of us. I don't feel bad. Let me put this link in here. So this is, so basically, and you can see by the picture here, we are looking at a stack of dominoes, or a row of dominoes, or however you want to visualize it, I guess. And we want the top row of numbers to equal each other. So after we rotate a certain amount of dominoes, they will all equal that correct pattern. The bottom part doesn't matter to us. We only care about the top. So as you can see in the first example here, we have a 2 here and the 2 here. So we just have, these are the 2 that we have to swap up. But some of the tricky parts are, what if this domino is first? So if you assume that your first domino and your AI, in this case, for your loop, is going to be 1 going all the way through, you're going to be sorely mistaken. So you'll get a wrong answer. So we have to ensure that we also compare this side to this side too, just to make sure. And conversely, this side to that side. So what we're going to do is, I think we did this the other day with 2 pointers technique. So basically we'll have the 1 pointer hanging back at I, and then we'll send another one up to the first one. And depending on how everything goes, this guy can go up quicker. So he might be the fast mover here. And then the guy in the back will be slower. They'll be testing against what the first pointer that's going out finds. So what that usually means to us is that we have to usually modify what our where our loop is going to look like. So in this case, because we're going and starting at the 0 index, and we're going to have a second pointer that'll start at least 1 ahead of our original index. So our I will start at 0, and our second pointer will just say J for now, starts at 1. As they iterate all the way through, I cannot iterate all the way through to the end of the array without J being out of bounds. So we're going to have to just kind of shorten our length of our loop when we do that. Okay. So as we get this, bug me probably more than it'll bug you. All right, so our understanding, so the big thing is if we can match up that top row, no matter what the number is, then we are going to return the number of rotations. So we're going to have two arrays that are going to be coming into our method, and we'll be spitting out an integer. And those arrays, I think, are integers, and I think they are, yes. So they're 1 through 6, so they don't get too crazy. Because it's dominoes for you, like a dice. I think those are probably pictures of dice, the way that they are, the way that they're set up and depicted. So, and if we can't rotate, if we can't match them up, that top row, then we're going to return a -1. And I don't think we'll have to do anything for a variable for that -1. We can just return -1. And we can probably do that outside of our iteration, out of our for loop. Because we can probably just, or maybe somewhere in the for loop, when we hit a stage where we can't go anymore. We'll have to see where the best place is for that return of the -1. Matching, I mean, these are just an array match. So, oh, there's 2 of them. It's a 2 pointers. I already said that, so that's kind of what I would imagine too. Is just any 2 pointer problem. But with a second level of searching. So we can do it all in the same thing too, with a particular statement in our ands, in our conditionals. So if we were to plan this out, I think we can do another base case if it's 0. So in that case, we would just, do we even need to? No, we'll think about it. Maybe we don't, maybe we do. I'll put the question marks there. Okay, so we're gonna need 2 variables. So we'll need a second pointer and a counter. And what we'll do is whenever we match up, we'll count. Or whenever we have to rotate, we'll count. Right? And we'll iterate. And we'll start 0 to length of array minus 1 because of the second pointer. Easy. We are going to have probably a crap load of, we'll have a big if else. So first will be if, so if, why does it have to be I equals AJ, so these are the top 2, then we'll, oh, what happened? I must get my mouse pad thing on my laptop. Then advance J. Second. And then else if. So if they don't equal, and if a I equals BJ, then we'll rotate. So in that case, we'll swap values, counter increments, and in this case, we should still, I think, move J forward. So and if we probably want to do, I'm going to copy this out. We're going to basically do the same thing again here. Because this will be, if, for example, when I said if this guy was over, if the 1 was in front of the 2, then stuff would change. So we'll make it so that AJ is equal to BI. So it'll be the opposite of the top one. I think we'll still swap values. We'll still increment both, and we'll be good. I think that's it. Oh, and if it doesn't work out, I think this is where we can else return the -1. And otherwise, we will return the comment. Right, that's the steps we're going to need. All right, so we'll go and grab this. And we'll make a new report. In this case, we'll go Domino notations. I'll post this in a second. Let me paste what's on my board out. Okay. This will be our new and final report for the evening. So we have min and dominoes. Can I copy that easily? Yeah. So public, static, and then I'll go to int. We're returning that. That's our title. And we'll have in int A, int B. I'm going to try without the base case. I don't know if I'm needing or not. So I don't think we will because it'll just go, it should just go right down to the else and return the -1. Yeah, so our second, so I'm just going to do, I always do the A and J because, I don't know, drilled into my head. And then I'm going to do results because it's really our counter, but it's my answer, so I want to just remember that that's the answer. And so we'll do our for loop. So the int I equals 0, and then we're going to go I is less than, so this will be A length plus A, they should be both equal, so A length minus 1 to make sure we don't get out of bounds. That's going to go down to this level here. And then we're going to go with our first if statements. And so if A at I, oh, sorry, J at line 6 is 1. We're starting 1 above, so that's our fast guy, or faster. They're moving at the same speed, really. But they're just incrementing one ahead of the other. So that will be AI equals AJ. That's all we need, right? So if that equals, we're just going to increment J. I will automatically increment in our loop. And then we'll have an else if. And there's a couple things here, so I'm going to use some brackets. All right, so we're going to swap. So in this case, we're going to do a temporary integer to hold our values. So this is always the tricky part. We'll start with the AI. I always get confused on this part. So we're holding the AI there. So we're going to put the AI value here. And what we're going to do is we're going to then take the BI value of I, and swap it up. So then in this case, we'll finish with BI, and we're going to give it back the value of AI from temp. That's always like the most challenging piece of code for me. I don't know why. So our counter is results. Spell result will be good. I'm going to implement that baby up. We'll take J and we'll implement J as well. And we'll be good here. Oh, and I did not have my conditions. So our conditions then are if A and J don't equal, and in this case, A is equal to this. Oh wait, no, this is not a J is equal to BI. So this is the example of where if 1/2 was the first iteration, we're swapping the that BI. And then we're just going to do the same thing over the next one. So I'm going to take U, we're just going to change the letters. So this will be AI, and this will be BJ. So if AI is what we need, and we need to swap the one ahead of us, we'll swap the BJ. So we're going to basically do kind of the same thing. So I'm just going to take this and try not to get into trouble. So in this case, we need this to be J instead of I for A. And BJ. Yes, because this is for the J. So. Right. And then we're going to do another result. We'll push this up. We'll get our J pushed up, and then our else. And because if none of this works out, we can simply return then the -1, because we won't have anything to swap because nothing will be equal to each other. And then we're going to finish our for loop. And then we're going to simply return results. And then we're going to quickly build a, oh man, activities. So both these are empty. Did I do something? No. Oh, that's you. Okay. Oops. No, I didn't push it for the class. I'm going to push it over for the class. That's why. All right. So we should be able to run, and we should get -1 because we have nothing there. So, oh, we get 0. Yeah, because we have to, but cannot swap anything. You can swap nulls, right? But you just do it 0 times.
Yeah.
So let's take the error-ridden one, or the one we can't swap. So this one should give us a -1. We cannot swap them out. -1, okay. And if we change this to 3, we should get 2. Okay. So that's the original one here. Using close to my class time. That should have been -1. What? Oh, did I do the same one? There we go. I should. Okay. All right. So then we'll go and put that in here. So this is my answer with the my comments that I had in earlier. And run the code. It's the same code exactly. And we'll submit. I had a little problems with this to begin with. Oh, what? Wrong answer. What happened? Uh-oh. Where did I change up? Let's see if we can figure this out real quick. So we got 3. Expect one effect. Well, we expect one effect. Output 3 expected 1. So is that simply flipping the first one? Man. Mess up all my numbers. So if all else fails, you run through the pi tutor and see what happens. Why are you giving me a weird answer? So J 10, that's 1. me just swap that back. Okay. All right, I see what's going on. I'm gonna have to figure that out, how to code that better. But I have to run to a class,
Okay.
so I'll post the change of the code on there. I don't know why. It's a bummer. Okay. Well, thanks for coming, Emily,
Yes, sir.
and maybe I'll see you next week. Definitely see you in
Yes.
class.
Oh, no, I'm not in that class. No, I'm not.
Right.
Is it software engineering?
No, I was going to say next week in programming languages.
Oh,
Yeah, and in Android.
yeah. I'm sorry.
Yeah, we don't do
No,
this.
I'm in Android. I thought you were talking about something else.
Yeah, we don't do this in software engineering. We do try stuff. Like this is how you plan out how you're going to do your work. It's really what it is.
Yeah.
So, all right.
Alrighty.